Great. Welcome, everybody. It's a chilly morning up here in Ithaca, New York. A little bit of snow flurries, but that's the way it is in April. My name is Jana Hexter. I'm happy to welcome you today to a wonderful webinar with Emily Unglesby, Michael Flessner, and John Wallace about their project GROW, bringing research and tools for integrated weed management to farmers. And before we get into the presentation, I am going to share a few little housekeeping things and introductions. So if you could go to the next slide, please. First, most importantly, is to acknowledge the funding for this webinar and everything that we do in the Northeast IPM Center. We are funded by a grant from NIFR, the National Institute of Food and Agriculture, Crop Protection and Pest Management Program, and the Regional Coordination Program. And that's part of USDA. And next slide, please. This webinar there is a live transcription option available for you, which should show up on the top of your screen that you can accept it if you would like. There will be a recording of this webinar, and it takes usually about a week for us to make some edits and put the slides together that come out to you in the Q&A. And I will send an email to anybody who's registered. We'll get an email with the link to the recording, so you don't have to worry about writing this down. Next slide, please. I am sure we'll get lots of questions. We usually do when weeds are the topic, and we love your questions. Please, though, for me, to make it a lot easier, if you can use the Q&A feature rather than the chat feature, and I will be monitoring the Q&A. I will not be monitoring the chat. So the Q&A is that box at the bottom or the top of your screen that says Q&A at the bottom. And there's also a little checkbox there where you can check to ask a question anonymously if you would like to. Next slide, please. And I am delighted to introduce our three presenters today. And the first is Emily Unglesby. She oversees outreach and communications for the GROW Network and helps manage the organization's website. Her background is in journalism, and she reported on crop production for DTN, The Progressive Farmer, as a staff reporter for a decade before her transition to GROW in 2022. And Michael Flessner is an associate professor of weed science at Virginia Tech. He earned his MS and PhD in crop, soil, and environmental sciences from Auburn University, and his current research and extension program focuses on solving weed management challenges currently facing Virginia, with emphasis placed on sustainable and economic solutions to problems like mounting herbicide resistance. He also co-leads the GROW Network. And our final presenter is John Wallace. He's an associate professor of weed science and extension specialist at Penn State University. His extension and research program focuses on developing integrated weed management practices in the field and forage crop systems that utilize no tillage or conservation tillage. He's also a member of the GROW Network's leadership team. Thank you. And before we begin, we have a few questions for you, which should pop up on your screen in a moment. And it's just so our presenters have an idea of who is on the call and what your interests may be. And we will also have a few questions for you at the end that helps them for designing future programs for you. So I'll be quiet while you answer those 4 questions. All right, I'm going to share the results with you. And let's see. It looks like there's a pretty good mix, actually, vegetable and field crops, and then some fruits, ornamentals, vineyards, and other. What best describes your profession? A lot of extension people, researchers, and 15% of farmer growers. That's wonderful. A few industry representatives and some others. How knowledgeable are you about integrated weed management tactics? Most people fall into somewhat and moderately knowledgeable. And how knowledgeable are you about GROW? 31% not knowledgeable at all, and 28% are only somewhat knowledgeable. So more than half the people don't have a lot of knowledge about about grow. And there are two people who are extremely knowledgeable. So thank you for joining us. All right. So with that, I will turn over the presentation to our presenters today.
All right. Well, good morning, everybody. Real pleasure to be on and to talk about GROW, which of course stands for Getting Rid of Weeds. We started in 2015, actually, with the leadership of Stephen Mirsky at the USDA Agricultural Research Service. Fortunately, Stephen couldn't be with us this morning, but with Emily and John Wallace, my presenter colleagues here this morning, we will hopefully get you well informed about GROW and who we are and what we do. So like I said, we started in 2015. We are a scientist-led network coordinating both our outreach and extension efforts to help farmers really across the U.S. fight herbicide resistance by diversifying our weed management strategies and really complement that herbicide use. As you can see here in the states in green, that's really where we have a funded public sector scientist helping us out with that network. We strive to be really a nationwide network with a universal distilled website of information on managing weeds, primarily in our broadacre crops, those field crops that was in the survey there. But hopefully you'll also find some things useful for the other crops that you might be growing. So we're in a lot of states. We're also in some other states. We've recently joined forces with Take Action. And so you might know Take Action is the United Soybean Board effort on fighting herbicide resistance, much like GROW is. So Take Action is focused more resources, on herbicides and sort of fighting fire with fire, right? What are our best herbicide practices to fight herbicide resistance? GROW has been more on the non-chemical sides, and so these are now together on one website under one umbrella, and Emily will talk more about that later. But a lot of the states that are in gray there, we're also part of that Take Action network. So really a national voice for the industry is our goal and what we strive to be. We also are part of the Better Together initiative. So that's another United Soybean Board initiative to get all the disciplines that help produce a soybean crop kind of under one umbrella organization. So GROW and Take Action for Weeds, Crop Protection Network, if you're not familiar with them on the pathology side, Science for Success on the soybean agronomy, and so on and so forth for all the disciplines we need to grow a soybean crop. So we strive to be nationwide. We are supported and funded by several different agencies. So I mentioned Stephen Mirsky at the USDA Agricultural Research Service is really our premier funder, but we also are privileged to have funding from the Natural Resource Conservation Service and several National Institute of Food and Agriculture grants within USDA. We're also supported by some farmer checkoff type organizations in Cotton Incorporated and the United Soybean Board. We have some partners on the industry side with Bayer and then the Bruin Engineering and Redekop, two equipment companies helping realize some of our harvest weed seed control research. And then we have in-kind partners such as WeedSmart, which is a very similar organization doing what we do in Australia. Okay, so what is exactly that we do? We really have sort of two main themes or pillars. We have our outreach and extension, and Emily will talk about that more later. And then we have within our research kind of three different themes under that. So currently that's harvest weed seed control that I'll talk about, and then John Wallace will talk about cover crops and our precision integrated weed management and sustainable agriculture. So let's start off with harvest weed seed control on the research side of things. And so what is harvest weed seed control? It's not necessarily a new practice, but it is still relatively unheard of in the United States. It's been in place for over 2 decades in Australia, and as the name kind of implies, it's all about managing weed seeds during the harvest operation. And so this is a picture of Ray Harrington's farm in Western Australia, and this is rigid ryegrass in a wheat crop. And Ray, like some U.S. farmers, are basically up against a major battle with herbicide resistance. And he basically came to the conclusion that he needed to do something about what you see in the picture here, is that when those weed seeds are above that cutter bar of the combine, they're going to come into the combine, and we're going to spread those seeds out across the field, probably drag them from one field to maybe a non-infested field with that combine as well. And so what can we do about that? And this is, I think, just really a major problem in the fact that these are the weeds that have beaten us for that year, right? They've beaten our herbicide program, they've beaten our crop rotation, they've beaten the crop competition. Whatever we've done for weed management that year, these weeds have beaten us, and then we reward them by spreading their seeds out, right? So surely we could do something about that. And he basically innovated to form or to make, along with some industry and university partners, what came to be known as the integrated Harrington seed destructor. If you could jump to the next slide, Emily. So that's the one there in the bottom left. So this basically is an attachment to the combine that, as those weed seeds come out of the back of it, what's coming off the shoe or the sieves, the chaff fraction, if you will, that's where the weed seeds mostly are, and we'll look more about that. Um, that is what goes into the mill and basically just mechanically damages them through these mills. There's two other mills on the market. There's the Redicop seed control unit, which is in the upper left, and maybe a picture is coming up of the seed terminator there. Yeah, so that's kind of an under the hood look, if you will, of the seed terminators. Of course, this would be sort of closed up during harvest, but you can see the openings in the middle of those twin mills. That's where the chaff and the weed seeds that are in the chaff fall into that. And then those screens are basically 5 different rings of stationary and spinning screens going about 3,000 rotations per minute. And so the seeds have to hit one of those things about 4 or 5 times before it can make it from the middle of those to the outside. And so it's really just a physical impact that's crushing the seed, that's damaging the seed, breaking the seed coat, and ultimately killing those weed seeds. So that's kind of the innovation that Ray Harrington and others have brought to the industry, is these seed impact mills, we collectively call them. Um, so we also see this issue in the United States, right? We have our own herbicide resistance epidemic, weeds like Palmer amaranth, um, common water hemp, the ragweeds. There's a whole plethora of herbicide-resistant weeds that we fight that are in our fields during harvest, right? So we figured we could try to look at this technology and see if we could bring this to the U.S. And so here's a couple pictures from some of my research in Virginia, the pigweeds in the upper left there, and then all those dark parts in that lower right picture are common ragweed that we have herbicide resistance to uh, in Virginia. So one of the first experiments that we did across the Grow Network looking into harvest weed seed control was really before we got any of this equipment and went straight to the field like that. First, we needed to know about what we're calling weed seed rain. When do those seeds shatter from that weedy plant relative to harvest, right? Because if the seeds fall off the plant before the combine gets there, the combine's not a vacuum. It's not going to suck those seeds up off the soil. Those are going to escape any harvest weed seed control practices. So we need a high retention rate of the seeds at the time of harvest, and hopefully for a little while after harvest, so that we don't have to get there at that very first opportunity for harvest. So across our network, we looked at 9 grass species and 13 broadleaf weed species, and also some drivers of seed shatter. And mostly what we found is that with the broadleaf weeds, we had, at the first opportunity for soybean harvest, about 80% or better for most weeds, and some weed species like the amaranthus, so Palmer amaranth and common water hemp, sometimes over 95% seed retention at the time of harvest. Of course, that kind of decreases as the weeks go by from harvest, as you would expect, but a really substantial opportunity. When you think about the broadleaf species, that really covers most of our herbicide resistance issues currently across the United States. The grass species was not quite as promising there. Within that sort of 4 weeks after the first harvest window or opportunity for harvest, some of the species had really lost almost 50% of their seeds to the ground. So I'm not going to say a complete loss of an opportunity for harvest weed seed control there, but certainly not as favorable as the broadleaf weeds there. Um, yeah, so we found that overall, though, promising, again, because most of our herbicide resistance is with the broadleaf species. So we wanted to go on and kind of keep further testing this. And so the next step in the harvest weed seed control journey, right, is okay, if the seeds are on there, we get them into the front of the combine, are they actually getting to that seed impact mill, or are they escaping the mill and going over the top of it, if you will, in the straw fraction? So if you're familiar with how the combines work, there's a rotor in there, and that has really the large residues, what I'm calling the straw fraction, and that kind of goes over top of the seed control seed impact mill through the straw chopper and spreader and then out onto the field, right? Versus if it goes down onto the sieves, it comes off in the chaff fraction, and that's what goes into the seed impact mill. So we want those seeds coming in, and we want them going to the impact mill, not escaping over the top. So what we found with this seed fate across some different scenarios here, if you can go to the next slide, please. We looked at the integrated Harrington seed destructor, that's the IHSD, in soybeans, and then the Redicop seed control unit in both soybeans and in wheat. So the percent passing through the straw, again, that wants to be a small or very short bar. And you'll see that that axis is at most 7% over there in the wheat on the right of the slide. But on average, across all these weeds and these two crops, we had less than 5% seeds escaping, if you will, in that straw fraction, which means over 95% are either going to the mill or they're going into the grain tank. And either way, we'll call that a win for weed management because they're going to be leaving the field or hopefully being killed in that seed impact mill. So then the next step is, okay, if they get to the mill, are they being killed? We did this testing in a couple different ways. One with the stationary test stands on the right, and then we did it during a harvest there, and you kind of see our setup on the left. So the test stands allowed us to test a range of weed species, as well as a different range of harvest conditions, flow rates, moisture levels, those kinds of things that were really hard to control for in the field. It also, farmers don't really want us pouring herbicide-resistant weed seeds in their combine into a clean field during harvest, right? So we were able to test a lot more species that way. But we did want to corroborate that and make sure that was a similar result we were getting in the field. So that you can see in that picture, there was a grad student kind of riding up in the engine bay and would pour weed seeds down a funnel and into a hose, and then that would feed a known quantity of weed seeds right into the mill during harvest there. So the first results we'll look at are just the test stands across our weeds that we tested in soybeans. So that's that left column is the species there, and then the center and the right columns are the two different seed impact mills that we were tested. And you see the lowest was giant foxtail, which is kind of bolded a little bit, hard to see there in the middle. So the lowest seed kill rate we got was over 98% seed kill with both of these impact mills. So across our soybean weeds, we're having really high success rates across, again, these range of harvest conditions that we tested. And that actually really worked well, or it was very representative of what we saw in the field as well. So there's three charts on here. Again, the IHSD and soybeans on the left, the Redicop and soybeans in the center, and the Redicop seed control unit and wheat on the right. And you see there we're getting over 99% seed kill across both mills in soybeans. The one species we had more trouble killing with than any others across the crops was annual ryegrass or Italian ryegrass in wheat. That just seemed to be the toughest seed to kill, and about 90% was what we saw, both with the stationary testing, which didn't show for the interest of time, but also here in the field with the Redicop there. So that's to be the toughest one, but still 90% effectiveness, I think, is very high, and something that I think people should be excited about. So where we're going now with this research is moving this on farm. Really, our question now is how many harvest seasons in a row do we need to successfully use something like a seed impact mill to start seeing effects show up later in the year? So we're doing that on farm with partners across our network with Redicops and the integrated Harrington seed destructor. And we've also added some chaff lining sites. And so chaff lining is another way to implement harvest weed seed control that's pretty similar to the mills, except that it's doesn't have really any more moving parts. It's more of just a funneling device to put the chaff and the weed seeds contained in there into a row across the field as the combine travels across. So you're not killing the weed seeds, but we're avoiding some of the issues that we've seen on farm with, you have to power the combine, so there's more horsepower use, and sometimes that results in the slowing of the travel speed of the combine. Obviously, that's burning more fuel, and so that can be an issue. And when we've gotten into some poor harvest conditions with higher moisture, we've actually seen these mills plug up in some cases, and that, of course, ultimately brings harvest to a stop, at least temporarily. And that's kind of something we'd want to avoid. So also wanted to look at chaff lining, which is really a trade-off here, right? We're not killing the weed seeds, but we are condensing them from spreading across, in theory, 100% of the field down to, however wide the chaff line is, typically about 18 inches. And so maybe about 10% of the field would have the weed seeds, but they'd all be condensed and hopefully competing with each other in that scenario. So we're doing this across what we're calling the WAC experiment: weed seed harvest and condense or kill. Condense being the chaff lining, kill being the seed impact mills. And within that, there's two crop rotations we're looking at: a corn soybean rotation that has 4 treatments, so with and without cover crops, and then also with and without harvest weed seed control. So all combinations of those two factors. And I really like that from an integrated weed management standpoint, because we have cover crops, hopefully suppressing weeds at the front of the season, which I'm sure many of you are familiar with, but John Wallace is going to talk more about here in a minute. We'll have the farmer would put out their herbicides, mid-season, and then the harvest weed seed control at the end of the season. And so we really kind of bracket the herbicide program with 2 other non-chemical approaches, and a really nice system there. We're also looking at this in wheat or rice, and there's a simpler experiment there of just with and without harvest weed seed control. So this is currently ongoing. We've seen some variation in results so far. So I don't really have anything concrete to share with you, but I will say in some locations, after 1 season of harvest weed seed control, we've seen a reduction maybe of about 30% in next year's emerged weed community. After 2 seasons, we've seen maybe 60%. In one published paper outside of our network, they had a 95 and 96% reduction of water hemp after 2 consecutive seasons of using a seed terminator. So we're seeing some sites move in the right direction fairly quickly. Other sites we've seen a non-significant result so far. And so how that interacts with what the starting level of the weed seed bank was, like if it was a very high infestation and a really high seed bank, then maybe it would take longer, right, for these reductions in inputs to the seed bank to pay off, right? Because we're relying on the seed banks to basically emerge, and then we kill those weed seeds to reduce the seed bank, and we're trying to stop inputs into it. So we're always kind of fighting on one side of that equation with with harvest weed seed control. So that's where we are with that. We do have something we can share here, which is that the combine performance of these seed impact mill sites. And so we've got the different crops that we've looked at this in: corn, rice, soybean, and wheat. I'll just draw your attention all the way to the right. That's an average across all the crops. And so for the IHSD, that was across 42 different comparisons, and the Redicop was 54 comparisons. And what we have here is fuel use on the top row, and then travel speed on the bottom row. And so the fuel use, we did have a significant increase, the IHSD, of an additional 2.5 gallons per hour to run the IHSD. And for the seed control unit, the Redicop, that was 2.8 gallons per hour. So not surprisingly, we know these are drawing horsepower, and therefore they're going to require more fuel to be burned in order to kill those weed seeds. But the other thing was, I think perhaps more concerning to the farmer, is that reduction in travel speed, which is the productivity of that combine. In Australia, they've seen basically about maybe on average a 10% reduction in the capacity of the combine when you equip it with one of these seed impact mills. So basically you took a class 9 combine down to a class 8 combine by adding a seed impact mill to it, or a class 8 down to a class 7. And you really need to be at class 8 or higher to use one of these mills. And so what we've seen across our sites with the travel speed was there actually not a significant change with the Redicop seed control unit, but a slight decrease, 0.35 miles per hour with the IHST there. So that's kind of what we have right now with the harvest weed seed control. We're taking this combine performance data and we're putting it into a decision support tool to try to get, what is the real cost to a grower in terms of a dollar per acre amount. And we're hoping that'll be coming up on our website here later this year. So that's our harvest weed seed control research. I think the plan is to take a quick break for questions now, if we have any.
Yes, we do. We have a couple of good questions. Um, um, the first one is, did you ever try to measure the population of weed seed survival versus impact mill versus untreated control plot and correlate with herbicide requirement usage, and also consider compaction issues and biological degradation of weed seed residue on impact mill treated plot?
Yeah, so I think what the question's getting at is not all of the seeds that enter the seed bank at the end of the season are going to survive the winter and then be a viable seed at the beginning of the next spring season. And so our comparisons in the field, at least, have have sort of taken that into account, right? Where we have the seed impact mill on versus where it's either off or we use a different combine for those plots. So you see so that overwintering effect would be sort of accounted for in that experimental design. I will say um, some of our earlier work that looked at a toe behind earlier prototype of the integrated Harrington seed destructor. At that time, it wasn't integrated; it was just the HSD, the Harrington seed destructor. Um, they took the survival, which again was like less than 2% of those seeds, put those in mesh bags over the winter, and then measured the survival of that. And there was a further reduction over the winter of the survivors through that seed impact mill, because sometimes the way we measured it was we would take the seeds, we'd put them into a greenhouse and see if they would emerge, right? But that, again, that's not really what's happening after a soybean harvest. They're going to be going into a field, have to survive the winter, and so if they do emerge because they had a damaged seed coat in a greenhouse, right, they would die with the killing frost in the field. So yeah, I guess trying to answer that question, and that has been accounted for as some of our analysis, and it basically goes the way you think it would, in that the winter is going to further reduce some of those number of surviving seeds, whether that went to the seed impact mill or not.
Great, thank you. And another question, any update on the weed chipper technology?
Yeah, so the weed chipper is another Australian invention. Basically, they would use cameras or some sensor to detect where weeds were in a fallow paddock, and so there's some like see and spray type technologies, right? They would spray only where the weeds were. This device would basically drop a tillage implement down and chip the weed out in that. So you sort of spot tillage, if you will, or targeted tillage. And to my understanding, that is still out there in more of the prototype phase. I'm not sure any equipment manufacturers picked it up to where it is commercially available just yet. But they have sort of innovated in terms of just a chipping device coming down and taking kind of a divot out of the field, almost like a golf swing would at a golf ball, to what they're calling, I think they were calling it like an active tool, where it almost just kind of undercuts the weed as it comes down. And actually, I think further reduces the amount of soil disturbance with that. So, they're still working on that, I guess, is the update there with the weed chipper. But yeah, another good IWM tool out of Australia to keep an eye on.
Okay, great. Wonderful. Thank you. Before we move on to our next presenter, I realized I neglected to say that the GROW team are the 2025 Northeastern IPM Center's Outstanding Achievement in IPM Award winners. And so that was the impetus for us asking them to present today. So I wanted to slip that in so it didn't go right at the end when people were ready to leave. So congratulations, folks. So, all right, I'll let you move on.
Okay, I think I'm next. Good morning. I'm going to talk a little bit about what the GROW team is up to on the cover crop research side when it comes to integrated weed management. And I'm sure that most of you are familiar, with the potential weed suppression benefits that come with cover cropping. A well-established, fall cover crop does a really nice job of suppressing weeds that have an overlapping life cycle. So winter annual weeds, and in conservation or no-tillage systems, it's an important tool for improving management of those no-till winter weeds and improving burn down applications. And then if we leave cover crops on the surface, they create a surface mulch and potentially help to suppress emerging summer annual weeds that would be emerging close to or after planting a summer annual cash crop. And so despite all these benefits, really short windows for establishing cover crops are one of the real limitations when it comes to cover cropping adoption in field crop systems. And so the interest in cover crops from a conservation benefit or a soil health benefit that's driving adoption is really a win-win when it comes to potential weed management benefits. And so our current research is really focused on an emerging practice called planting green. And that just really kind of defines the practice of delaying termination of cover crops until at or after planting a summer annual cash crop. And so this is done in both corn and soybean production systems. And growers who've adopted this practice are interested in achieving continuous living cover. They're interested in growing more biomass out of their cover crops to really drive those soil health benefits, whether it's the carbon inputs, improving organic matter over the long term, or increasing soil water infiltration, or increasing soil biological health metrics as well. And so we're interested in that practice because one of the outcomes is to potentially produce more biomass. And so the picture I'm showing here is, planting no-till soybeans into a cereal rye cover crop that's at a pretty early growth stage, and that might we see a lot of that happening out on the landscape, and we also see growers who are allowing that cover crop to get to an even later phenological stage where we might see a large jump in biomass production. Typically, they might be using roll crimpers or other residue management tools to manage that residue to create a surface mulch to plant into. And so really what we know from kind of foundational work in cover crops is that the level of weed suppression that we get from a cover crop surface mulch is really a function of biomass. And we also know that kind of the relative impact of increasing biomass is going to differ among weed species. And the figure I'm showing is just a little data from a greenhouse experiment that a graduate student in my lab had conducted, which demonstrates the differences in seedling survival of weed species underneath and emerging through a cereal rye surface mulch. The x-axis is really describes seed size relative to a crop mass. And so the blue dots are larger seeded species, things like morning glories or cucumber, and those larger seeded species can emerge through high levels of biomass, whereas smaller seeded species, we see much greater seedling mortality. And this is important because many of the herbicide resistant weeds that are problematic in no-till systems are these small seeded species. So things like Palmer amaranth and water hemp are good examples. And so achieving greater biomass is going to produce some variable results when it comes to weed suppression. But research suggests that we're going to have a larger impact on some of those really economically important species that are resistant to different modes of action. Next slide, Emily. Another kind of important piece of context for this practice is how growers think about termination timing of a cover crop in order to manage early season soil moisture. And so growers who've adopted this practice really think about termination timing as kind of an adaptive management practice. So in wet springs, they might allow that cover crop to continue to grow and pull soil moisture out in order to create better field fit conditions to plant into. Whereas if it's a dry spring and there's no rain in the forecast, they might go ahead and kill that cover crop early just to preserve soil moisture. So the figure I'm showing here is some data from some field trials conducted at Penn State looking at the effect of termination timing on soybean production. And the departures that you're seeing in soil moisture across time between the green, which is a planting green treatment, and the brown, which is an early termination treatment. You can see after we've killed that cover crop and we've gotten some rain, we see an increase in soil moisture where that planting green treatment continues to pull soil moisture out. So that can really influence early season soil moisture conditions. And that's also going to have an impact on things like weed emergence timing, germination timing, and potentially activity of herbicides or herbicide efficacy. Next slide, Emily. Thank you. The other part of that soil moisture story is that when we generate greater amounts of biomass that's on the surface due to improved soil water infiltration, where we often see a soil moisture benefit later in the season, closer to when that grain is being filled in these summer annual cash crops. And so this is also a potential benefit of planting green or generating more biomass, is this soil moisture conservation benefit in drier summers. Emily? So it was really this context and kind of what we've learned from early adopters of the practice that kind of informed the design of our current experiment. And so we are just about to enter our last production year of a 3-year experiment. It's being conducted at 9 locations, and we have a really nice gradient across different institutions as far as different soybean production regions. So we have 2 locations kind of in the mid-Atlantic here in Pennsylvania and Delaware. We have 4 locations kind of stretching across the Corn Belt, from the Eastern Corn Belt in Ohio, 2 locations in Illinois and 1 in Nebraska. And then also some more southern production systems, including Kentucky, North Carolina, and the University of Georgia. So really nice range of kind of environment and management conditions to evaluate this practice. And at each location in each year, we're conducting this experiment in 2 different kind of crop sequences that are typical to the region, where you might be rotating to soybeans. And so when it's all said and done, we'll have 54 site years of data to evaluate kind of weed management implications, which is a lot of data, and will really allow us to pick out important patterns that can help improve management recommendations. And so the way the experiment is designed, it's a very simple experiment. We just have a no cover crop control. We have a standard termination. We're using cereal rye, so we'd be terminating cereal rye ahead of soybeans between 14 and 21 days prior to planting. And then a planting green treatment, where we would plant directly into standing cereal rye and then terminate it after. We have a herbicide input gradient. So we kind of have a control where we're just terminating the cover crop and then using post herbicides to manage weeds in crop. And we're comparing that to really a 2-pass kind of standard industry practice using a strong foundational pre-emergent herbicide in combination with a post application as well. So next slide, Emily. And so the other thing that we're doing is we're taking what we call demographic measurements of weed populations at really important decision points when it comes to weed management, control decisions. And so we're taking multiple measurements early in the crop growing season, as well as late in the crop growing season, and looking at kind of population density and the structure of populations for 2 different groups of weed species. So each location has a small seeded amaranth that they're focusing on. So that's Palmer amaranth in some locations, water hemp in others. A few are just looking at red root or smooth pigweed. And then each location has chosen really a driver, large seeded broadleaf species to follow as well. So a good example of that for some of our folks out in the Corn Belt would be giant ragweed, which is a troublesome multiple herbicide resistant species in that region. Next slide. So I'm not going to show a whole lot of data because we're generating a lot, and so really the important outcomes will come from the synthesis of all those site years at the end of the project. But I just want to demonstrate the types of questions that we think this experiment will help to answer. And so the first set of questions is really about the relative gain or relative benefit of delaying termination of a cover crop when it comes to weed management goals. And so we're going to be able to really define kind of what the kind of average cover crop biomass production is when we're using standard management practices across these soybean production regions and what the relative gain is in each one of those regions when we delay termination. And so it's the case where, some of our southern locations, because the cover crops advance phenologically so quickly, that there's hasn't been a tremendous gain in biomass production when you delay termination, whereas in other locations, we see a really significant advance in biomass accumulation when we delay termination. So with that type of data, then we'll be able to ask, well, what is the relative gain in weed suppression potential? So, how well do we do in driving down weed populations that we're targeting with post herbicides? And then we'll also be able to ask how weed species that differ in seed size respond to those changes in biomass. Next slide. And then because we have this herbicide gradient, we'll be able to really contextualize kind of how we can think about integrating herbicide program approaches with delayed termination of cover crops. So one potential benefit of planting green is it may allow us to reduce herbicide inputs, either through the number of passes or the number of active ingredients. The goal was always to limit the number of weed escapes and achieve a high level of weed control and really prevent weed seed rain. So we may be able to understand what the conditions need to be in order to limit weed escapes while also doing that with reduced herbicide inputs. It's also the case that for a number of these weed species, it's likely necessary that we need to integrate herbicide, two-pass herbicide programs with this cover cropping approach. But what we're interested in is understanding under what conditions does the combination of, let's say, a pre-emergent herbicide combine with cover crop residues to provide kind of a synergistic effect where the combination of those tactics provide higher levels of weed control compared to the sum of either one of those tactics alone. Next question. And we're also hoping to kind of advance our understanding of how cover crop termination impacts soil water or soil moisture dynamics early in the season. And if that in turn impacts weed recruitment patterns, herbicide efficacy, so kind of translating that to some weed control implications. And so we've installed water sensors in a replicate of each one of our treatments, and we're monitoring soil moisture prior to termination and then through the crop growing season at 2 different depths. And so that'll provide us some really good data to understand the termination effect on these weed control implications. Next slide. And so what we're hoping to do is kind of take the first steps to understanding what the potential is for developing decision support tools related to termination timing and its impact on soil water management. And so one of the things that we're going to do is to ask whether we can use the data that we've generated and develop process-based models that relate termination timing or allow us to predict the water use of a continuing cover crop that's allowed to continue to grow. And so if we know kind of the phenology of that cover crop and the current soil moisture, we might be able to predict whether we can afford to allow it to grow or if it'll have a significant impact on soil moisture dynamics. This also has potential implications for starting to think about precision kind of weed management strategies. Right now, there's planter-based technologies that can measure soil moisture in the seed furrow as well as soil temperature. And so we have the potential on the landscape right now to provide pretty high levels or a lot of detail when it comes to soil moisture variability at the time of planting within fields. And so we might be able to use that data in relationship to weed distribution patterns to understand how these dynamics are impacting weed recruitment within fields. Next slide. Okay, so that's a good opportunity to just transition and talk a little bit about kind of the development of decision support tools that can really inform precision ag practices when it comes to weed management that GROW's involved in. And so there's a number of GROW members that are actively involved in this effort to create a national ag image repository. This effort is really being led by Stephen Mirsky at the USDA Beltsville ARS station, as well as Chris Reberg-Horton at NC State and Texas A&M, and a few other folks across the country. And the goal of the National Ag Image Repository is to really create an open access repository of both weed species, as well as cover crops and major cash crops as well. And so there's been a long kind of period of protocol development in order to do this with really, a high level of precision. So there's been kind of semi-field protocols that have been developed, and it's now moved to being done in field, where there's a lot of folks like myself that are helping to capture more images of more weed species. Next question. So, this is a map of where folks are located that are participating in this project. Again, both NC State, USDA Beltsville, Texas A&M are really the lead institutions. And then a number of folks that are doing protocols across the country to generate more images. So right now, there's 38 weed species that we have a repository for, 15 cover crops. I know this year we're spending a lot of time taking images of cover crop mixtures, as well as 3 different cash crops. Next slide, Emily. So I'm just going to end here with a couple of examples of kind of the potential for tool development related to the National Ag Image Repository. And so one is that we know that cover crop performance is highly variable within fields. And so I just talked about the value of producing high levels of biomass for weed suppression. And we can really see significant variability in biomass production of a cover crop within field scales. And that is due to a number of different reasons. A lot of them are kind of bottom-up abiotic processes that influence biomass potential. So the ability to be able to map cover crop species and also predict the amount of biomass that is present at the time of termination could really help to design kind of precision strategies. And so an obvious example would be that we can think about growing a legume cover crop or a grass legume cover crop and the potential nitrogen credit, where we might design for, prescription or precision fertility strategies around kind of the nitrogen credit related to the cover crop. And so this approach, we can start to get at developing, using cover crop images to develop precision fertility maps. Next one. Okay, so the other thing that's I think is going to really generate a lot of value out of this effort is that there's an effort within this project in developing really low-cost platforms to do these imaging types of protocols. And so this is really accessible to researchers. And so, researchers across the country might have different applications for using these kind of high resolution weed or cover crop kind of imaging maps. And so there's been 2 kind of technologies that we've been working on within this project. They're both essentially taking 2D images and then reconstructing them to produce 3D images that allow us to estimate things like biomass and differentiate between species. And so right now, we're working on these technologies in the hopes that we could mount them onto different pieces of equipment and employ them for different research purposes. Next slide. And of course, already right now, commercially, there's, targeted spraying technology that's available, at a national level. The John Deere See and Spray is a good example. And so what the data that's being generated through the GROW network, we're making advances in being able to distinguish between weed species. And because this is an open access kind of technology, it allows companies that are interested in developing other precision weed control strategies that might be non-chemical based. So using laser weeding or thermal weeding or electrical weeding tools in this kind of real-time precision kind of framework. And so that's where we're hoping that this effort is going to go. And it's been really exciting and really a lot of work by a number of folks to realize some of these technologies. So with that, I'll stop. I don't know if we have time for questions.
We do indeed, and we do have a number of questions. And just so folks are aware, this webinar is going until 12:30. And I know a lot of people may have to leave at the top of the hour. It is being recorded, so whatever you miss, if you have to leave at 12, you can hear it. But we will carry on with the presentation and more questions until 12:30. So a couple of questions here is, have you looked at survival of predators with the delayed cover crop termination?
Survival of predators?
Yes,
I assume like weed seed predators?
I'm assuming so.
Yeah, so we haven't specifically looked at that, but that would be a great question. I think we would assume that continuous living cover or kind of as well as the habitat that's created by more cover crop surface mulch is going to influence the habitat of some of those seed predators that are working on the surface. So that's, I think, something worthwhile to look at. We know that weed seed predation can be pretty significant in no-till systems. It's somewhat also species specific, but I think it's a great point.
Okay. Another question is, are these spray down or roll/crimp down covers?
Yeah, sorry, I kind of skipped over some of the details. So our experiment, all the treatments include a burn down application of the cover crop. And many of the locations have residue management tools, including either integrated roll crimpers on the planter or front mounted roller crimper. And so, yes, we're roll crimping in the planting green treatment if the cover crops are getting to a stage where it makes sense.
Great, thank you. Did you measure biological degradation of weed seed population because of cover crop treatments and how it helps in moisture conservation for grain crops?
So we have not looked at kind of the another great question about kind of what I kind of think of as kind of the potential indirect impacts of how we're managing cover crop residues on the fate of weed seeds in the seed bank. And so what we do know is that, in no-till systems, weed seeds that are close to the surface are going through a lot of wetting and drying cycles. And that when we have cover crops there and when we have the cover crop surface mulch in place, we have fewer kind of the magnitude of increases and decreases in soil moisture as well as soil temperature are kind of muted. And so that's likely to impact, kind of degradation of seed coats and that kind of thing. We have not attempted to answer that question. The question about soil moisture conservation related to soybean production, I mean, we're certainly taking soybean yields. And so we're hoping that we can kind of ask questions due to the number of site years that we have in whether when we see differences in soybean yields, if there's a signal related to kind of soil moisture dynamics. So that's something that we're hoping to answer. I did the graphs I showed from the work that was done in Pennsylvania. Attempt to measure soybean stress. They took different measurements to measure soybean stress throughout the season, and did detect a kind of a benefit from planting green and reducing soybean stress through the middle part of the summer. It didn't always translate to a gain in soybean yields, but they were able to kind of document that there's certainly a physiological response related to that.
Thank you. And we do have a couple more questions, but I'm going to have us move on to the next part of the presentation, and we can answer those questions at the next break.
All right. Well, thank you everyone who's held on with us thus long, and just a little bit more time here. I just want to talk a little bit about GROW's outreach platforms. So John and Michael have covered a lot of the research projects that are affiliated with GROW, and our outreach platform does cover a lot of that research, and we keep you up to date on it, but it's also sort of a larger engine that we're using to talk about and educate on integrated weed management tactics really across the industry. So you'll find a lot there. We try to have a good variety of text, video, photography, digital tools to meet people where they learn best. So the website is www.growiwm.org, and our target subscribers are really this nice mix that we see here on the webinar today. Farmers, the advising consultants that serve them, ag scientists, media outlets, and a lot of government organizations sort of make up the folks that subscribe to our website. And I'll dive into more detail on some of these as we go on, but just briefly, some of the big resources there on the website are this Weed Management Toolbox, which is full of educational web pages on all the various IWM tactics out there. So Cover Crops has a couple big weed pages, Harvest Weed Seed Control, but also emerging technologies like weed electrocution and precision sprayers. They all get a web page. We also have a library of weeds that goes through the identification of major weeds, but also how to manage them with herbicides, but also IWM. And we have a lot of educational pages just on what integrated weed management is, what herbicide resistance is, and how to manage it with integrated weed management. And then finally, a news page that we update weekly with news stories on these research projects, but also anything interesting happening in novel or integrated weed management tactics around the country, really. And our newsletter goes out just once a week telling you what we've published on the news page that week. We also have an array of social media platforms, and I'd encourage folks to follow us wherever you're most comfortable. Our biggest, most active platform is probably the X Twitter one. We do weekly and sometimes even daily posts on news and events and places we're traveling to in our different social media campaigns. We also have a very robust YouTube channel with a lot of videos, and our Instagram and Facebook pages are also pretty active at least once a week. We're posting about the news that we're covering. And then, of course, we have a LinkedIn profile. And so the educational web pages that GROW creates really start with scientists. That's very much scientist-led content. And they're written by someone who has a fair amount of expertise or a lot of expertise on a particular topic. And then the GROW outreach team edits them just to make sure that they are, at a certain readability level, but then they go out again for a peer review by an outside scientist. So at the end of the day, these are pretty robust extension publications, and we're always sure to list all of our authors and editors and reviewers and all of the resources we've used to build these pages. So this is sort of the big ones I've pulled out here. Our basics of herbicide resistance and how to manage herbicide resistance are probably our two most recently updated pages, put together by Bill Curran, who's an emeritus professor at Penn State. And then we also have a couple series on what is integrated weed management, which is obviously sort of the basics. And then our weed management toolbox, which I mentioned before, and you can see the array of tactics there that we have educational web pages on, and we're constantly updating these pages and adding new ones. For example, we have one on weed electrocution coming later this month. But we also have a big portion of the website devoted to farmer-led education, because we know this is perhaps farmers' preference for learning about new and novel tactics. They really want to hear from other farmers who have tried it out on working farms and worked through it that way. So we have a couple pages devoted to this. The Grow Farmer case studies are short videos that had been created by one of our outreach specialists, Claudia Rubione, and they showcase these innovative farmers that are really trying new things. They're talking about what they're experimenting with, or they're talking about an integrated weed management tactic that they've really mastered on their operation. And these videos range from about 3 to 6 minutes, and you can find them on this farmer case studies page under our integrated weed management tab. The other farmer-focused content is from our Grow Farmer forums, which are educational webinars like this, but they're really driven by a farmer panel. We find farmers who have a lot of expertise and knowledge on a particular IWM tactic. We're working on one on weed electrocution coming up. And a scientist sort of guides the conversation, but it's really a chance for people to just hear how these farmers are using this new tactic and what they've learned. And those you can find under our resources tab, all organized together by topic. And this is a fairly new resource put together by a big team of scientists. It's called the Weed Management Planner, and it's 2 charts, one devoted to before planting, one to after planting. And the goal was to just provide a sort of quick reference chart for farmers to look at their individual weed species across the top of the chart, and then these common crop and weed management tactics down the side. So you can see them here: crop rotation, cover crop use, tillage, planting dates, fertility practices, harvest weed seed control, and of course herbicide use. And you can see very quickly via this rating system how each individual tactic is going to affect that individual weed species, because we know that, for example, tillage makes some weeds worse, but no-till practices can make other weeds worse. So it's just sort of a very quick reference chart for a sort of holistic view of how your entire farming practices are affecting your weed spectrum. So these are big posters. So you can go to the Weed Management Planner page on our website and download the PDFs, but we'd also encourage you to take advantage of the free print orders that we offer. You can order about 50 of each for free. They're great educational tools. And another recent publication is from John Wallace, whom you just heard at Penn State. He created this cover crop termination fact sheet series with help from a team of scientists in the Mid-Atlantic and the Midwest. And it covers 4 big topics. The first fact sheet really sort of is an overview of herbicide application best management practices for terminating cover crops. And then the second one digs into how to select a good, robust herbicide program to terminate your cover crops, how to integrate herbicides with roll crimping, because we know that's an increasingly common practice. And then finally, an entire fact sheet devoted to how to control annual ryegrass if you opted to use that. And these are also available on one of our educational web pages, cover crop termination practices in the weed management toolbox. And this is sort of a peek at a digital tool coming soon. This will be a browser-based, but hopefully will work just fine on mobile as well, decision support tool. And it's just trying to give farmers a quick look at how effective their herbicide modes of action, their herbicide plan is for that season. So you'll go through and you'll enter your field location, the crops you're spraying within, the weed spectrum you're targeting, cases of herbicide resistance in your region. And if you don't know, we have an underlying survey that can help alert you to cases. And then what herbicides you are applying for the different timeframes: burn down, pre-emergence, and post-emergence. And then it gives you this final sort of overview of how many actual effective modes of action are going to be in your program based on the weeds you selected. So it's looking at 2 things. First, the actual efficacy of the herbicides you picked against that particular weed, but then also whether or not the herbicides you have picked are compromised by known cases of resistance in your region. So This is going through development right now, and there will be some pretty significant design changes, and we're hoping that this total effective mode of action, for example, will be much more visible in the final product. But we're hoping in the next season or two, we'll be rolling this out, and it'll be available on the website. And then this is something Michael alluded to early on. The Soy Checkoff's Take Action Herbicide Resistance Management Program is now found on the GROW website, and we're managing the outreach and communications for that. They have some wonderful resources. Some of you might be familiar with Take Action's other resources for fungicide resistance and insecticide resistance. Those are still living on the legacy Take Action website. Only the weed-specific content has moved to the GROW website. And of that content, I want to just highlight a couple resources that I think would be really interesting to this audience. The first is the Take Action Herbicide Classification Chart. This is created by a Michigan State scientist every year, Christy Sprague, and she updates it every year. It has two primary sections to it. The first is just a listing of all of the herbicide sites of action, and then each active ingredient commercially available within each site of action. And then even more helpful, I think, is this huge breakdown of every commercially available herbicide premix product on the market in the major row crops, broken down by their active ingredients and then the sites of action associated with each active ingredient. So just a tremendous resource for farmers and crop consultants and educators who are dealing with this huge alphabet soup of herbicide products every year, which change slightly or change names. And these are also available up to, I think you can order about 250 of them for free to hand out to farmers and groups that you meet. And finally, the other Take Action tool I wanted to draw your attention to is this. This is sort of a digital companion to the chart, and it's called the Herbicide Site of Action Lookup Tool. And it allows you to search your herbicide by brand name or by active ingredient, and it just very quickly generates the sites of action within that product as well as the individual active ingredients. So just sort of a quick look at what you might be putting in the tank. And finally, I would encourage everybody who is interested in what we're doing to subscribe to our website. Every web page you're on should have this floating subscribe button. On the GROW pages, it will be green. On the Take Action pages, it will be orange, but this just gets you the weekly update from GROW once a week on Wednesday with our latest news stories, but we will occasionally also send out alerts about upcoming webinars or events we're going to be at, but no more than 1 to 2 emails a week. So pretty light lift and some really good information that hopefully people here would be interested in. So that's all I have from the outreach side. And I think that we can finish up questions now.
Yeah, we have a couple more questions. Thank you. A lot of wonderful resources. That's great. So, okay. So, which is better in sowing cover crops, before or after or with main crops?
So I guess if the question, I guess I'll try to answer the question as I interpret it. Most of the work that we've done looking at cover crops in these systems, we're post-harvest seeding the cover crop after we've harvested corn or soybeans, and then we'd be terminating it, close to planting. So that's the primary method that we've investigated when it comes to planting green. There are intercropping approaches for establishing cover crops. So we here in Pennsylvania have done a lot of work at looking at drill interseeding cover crops into corn as an establishment method. One of the challenges with then using that establishment method and then using a planting green practice after is that some of the species that work best in that kind of intercropping strategy are not the best species for achieving high levels of biomass or roll crimping them to establish a surface mulch. So for example, annual ryegrass is what we found is to be the best grass cover crop for establishing a cover crop using a relay cropping practice, whereas a winter cereal like cereal rye or wheat or triticale is a better kind of cover crop for post-harvest establishment where you might use a planting green practice into soybeans. So I hope I've answered that in the right way if I understood it correctly.
Great, thank you. And I think this is a question for Emily. It says, does it showcase areas of herbicide resistance across the state and Canada on different modes of action and weed species? I don't know what the "it" is, so I'm wondering if that might be the website. But
Or maybe the Check My Herbicide Plan app.
mhm.
Yeah, so that's a good question. And Michael's actually done a lot more work on the physical construction of the app. But to my knowledge, it won't have sort of an overarching map, will it, Michael?
No, we weren't incorporating that. We're actually hoping that as you go through the app, it asks for known herbicide resistance because we think even we try to do our best based on expert opinion to get it to the county level. Of course, that's changing every season where these are as they spread. So rather than sort of relying what we have, although we do have a database in the background, we'd really like the user to input, their experience. Do they know they have herbicide resistance or not? To then the app would use that over what's in the background. But there is a map in the background, although that is again difficult to keep up to date and is sort of a secondary step in the app, so that it's not really an exact science, right? It's hard to document herbicide resistance in every county, let alone every field within a county. So sort of struggle to answer that question, but I think that gets at the answer there. So, but no, you can't just see a map.
All right, thank you. Another question is, do you study the relation of cover crops and pollinators and increase in yield?
We have not within the GROW project. I know it's certainly one of the ecosystem services we think about when it comes to cover crops. And so there are some studies that have tried to kind of define that benefit, but we've been pretty much focused on kind of the integrated weed management implications of cover cropping within the GROW project.
Great. And I think, Jihad, that you may find some information if you look back on some of the toolboxes that we have done on pollinators and cover crops. We've done several webinars on cover crops and several on pollinators. And off the top of my head, I can't think of if there was a combination, but if you go back and look on our website and the Toolbox webinar series, you may find some good information there. So, all right. And then the last question we have from Vijay Nandula is, any update on OTT applications of dicamba in 2025?
Sure. So OTT, over the top applications dicamba in 2025. So in the Extend Flex cropping systems, so mostly that's soybean in the Northeast, but it would also apply to Extend Flex cotton as well. There's not any products labeled for over the top dicamba within those systems. So that would be Ingenia, Tavium, and XtendiMax would be the three products that applies to. I guess I would caution this that there is still dicamba for uses in other crops, right? So if you use dicamba in corn or pastures or turf systems, right? Those are different products than over the top in XtendFlex systems. And so there's not any changes to those dicamba uses for the 2025 season.
Okay. And then for 2026, any update on new AIs for corn and soybean from FMC?
So I know they have announced that they are anticipating some, in development still. I don't know that there's really any updates other than what they've posted publicly. I don't know, John, if you know anything further than that, but they are anticipating some new eyes coming to those markets.
Okay, and I think that is all our questions. So thank you very much. And we have some questions for you. You should see another poll pop up that will help us gauge the usefulness of this, but also for Grow about what you're interested in seeing going forward. All right, and I will share the results with you. So a shift in how knowledgeable you are about integrated weed management, that's moved all up to moderately, very, and extremely. How knowledgeable are you now about Grow? We've got lots of people who are knowledgeable about Grow. As a result of this, how likely are you to use the integrated weed management resources available at Grow? And that is extreme, over 70% are very likely, extremely likely to use them. And of all the topics that we've heard about today, which are you most likely to use? There's a really good spread there. So it's like a lot of interest in a lot of what was shared. And there's a couple of long answers which I cannot share here, I think. And how likely are you as a result of this webinar to increase use of integrated pest management? And 50% said yes, and 20% very likely. So that is over 70% from today, which is music to our ears. I just have one other thing to share with you, a couple of other things to share with you. We have a webinar coming up at the end of April on pesticide label changes brought on by the Endangered Species Act. That's with Nirjana Krishnan. Oh, I think I've left off an N at the end of her name. Kurt Vollmer, Bill Kism, and Mark Van Gassel. And you're welcome to sign up for that presentation. And next slide, please. If you would like to be in contact with fellow colleagues who are interested in weed management and IPM, we have a place on our website where you can put a profile about yourself. And you can also go there and see who's put on profiles. So you can find colleagues that are working, farmers and researchers, and find each other. And next slide, please. As I mentioned, there is a recording of this webinar that is going to be available. It usually takes us about a week, so it won't be out tomorrow, don't worry. And I will send you an email. And I think that may be the last slide. It is indeed. So with that, I want to say thank you very, very much for the presentation and all of the work that has gone into putting together such informative resources and great research. And I'm sure it was really helpful for people who joined us today. So thank you very, very much. I appreciate it.